Hey guys, on page 3 we have what's called a decomposition reaction. Potassium chlorate is decomposing to make potassium chloride and oxygen gas. Potassium chlorate is a type of accelerant used in fires or any kind of explosion or rocket fuels where what you need is an additional amount of oxygen in the environment. This reaction can be used to produce more oxygen gas fueling that fire. How many moles of O2 form as 3 moles of potassium chlorate are totally consumed? When we start with 3 moles of potassium chlorate in the upper left-hand box of our conversion, and then we use the balance reaction to relate 3 to 2. 3 moles of oxygen are produced for every 2 moles of potassium chlorate consumed, and then 3 times 3 is 9, divided by 2 is 4.5 moles. How many grams of KCl will form from 4.5 moles of potassium chlorate consumed? Here, 4.5 moles of KClO3 is in the upper left-hand box, and now this time we want to relate it to KCl. So we find that there are 2 KCl's for every 2 KClO3s. And yes, this is something that reduces to 1, but you still want to show this step in your reaction to show me, your teacher, that you've gone through this thought process and that you did not just arbitrarily or accidentally just leave out this step. Finally, once you've converted to moles of KCl, right, moles cancel, you are not finished because you need grams of KCl. Using the molar mass of KCl, where you add up the mass of K and Cl, you get 340 grams of potassium chloride. Remember, when you're doing mole conversions, you need to be first in moles before you can use the mole ratio in a balanced reaction. Question 14 asks, sodium metal reacts with water to produce NaOH according to the following equation. We actually did this reaction in class. When we put the sodium in water, it also produced a lot of energy. Pure sodium wants to give away its 1 valence electron so vigorously that a lot of energy is produced in this process. How many grams of NaOH are produced if 20 grams of sodium metal react with excess water? I know the actual test here, the practice test said oxygen, but that's a typo that should say water. If we start with 20 grams of sodium metal, we cannot relate it to anything else in this particular reaction until you convert grams to moles. Remember that moles are the universal converting factor. We use the periodic table to convert grams of sodium to moles, and then we use the mole ratio of 2 to 2, 2 moles of sodium hydroxide to 2 moles of sodium to convert sodium to sodium hydroxide. Always remember the diagonal rule. Converting moles of sodium across diagonally, these units have to match. Now that we've got moles of sodium hydroxide, we have one more step, using the molar mass of sodium hydroxide to convert it to grams. NaOH, 34.8 grams of NaOH. I know we've talked about this a lot in class, but I'll remind you one more time. Everything across the top is multiplied, and everything across the bottom is divided. Of course, we can ignore the ones because either multiplying or dividing by 1 does not affect your answer. The last problem on this page, question 15, asks us, what is the limiting reagent in a chemical reaction, and what is a reagent in excess? You know, reagent in this sense is just another word for reactant. Historically, it was called the limiting reagent. Typically today, unless we're talking about it in this specific context, we call them reactants, but they're really the same thing. Which determines how much product is formed and why? The limiting reagent is what determines how much product is formed because it's what runs out first. And when it runs out, it stops the chemical reaction. How much product you get is therefore dictated on when the reaction stops. The reagent in excess is when you have leftovers. It's the reagent that you have left over because it is not limiting. If you have a reaction in nature, typically one is limiting and one is in excess. It's possible with a reaction that you set up in the lab to create a scenario where they both run out at the same time, but the vast majority of reactions that is not the case. Instead, you get situations where one runs out first. That's why we always use the limiting reagent for all of the math. That concludes the video for page 3.